Welcome everybody to the ASIC virtual sponsor series. Today our series is about reliable ozone measurement at scale, applications of the Clarity Ozone Module for air quality research, modeling, and management. This series has been developed for our sponsoring partners to educate you on the work they're involved in. This session is sponsored and developed by Clarity Movement Co. in partnership with 2B Technologies, and we're very thankful for their sponsorship. Now, before we get started, I'd like to cover a few notes. All attendees are in listen-only mode right now. If you have any problems during the webinar, please use the chat function to send a message to myself or one of the panelists, and we will be happy to help you. If you have any questions for the presenters, go ahead and type it into the Q&A box at the bottom of your webinar screen. During the live Q&A portion, the moderators will share your question with the presenter and they will answer it. When you put any information in the chat box to start a discussion with other attendees, please make sure you send it to everybody. That way others can see it and respond as well. And of course, this meeting is being recorded, so we will share the recording with the public after it has finished. Now, I see a lot of people are adding their names and affiliation to the chat. That is wonderful. Please continue to do so we can have conversations throughout this webinar. Now, I'd like to pass the mic virtually to Ryan Higgins, Clarity Movement Co.
Thanks everyone for joining our ASIC workshop on reliable ozone measurement at scale. We have a great panel here today to talk about the current state of ozone monitoring around the world and how we can use new ozone monitoring technologies to improve our understanding of the health impacts of this pollutant. So we have Owen Cooper, a senior research scientist focused on regional chemical modeling at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado. Also joining us is Gordon Pierce, the Technical Services Program Manager for the Air Pollution Control Division at the Colorado Department of Public Health and the Environment. We have Jessa Ellenberg, the Director of Educational Outreach at 2B Technologies, and Paolo Michelizi, Chief Technology Officer at Clarity Movement. So I would like to remind everyone that there will be a live Q&A session at the end of this event. So please remember to submit any questions you have for our panelists through the Q&A box. And with that, I think we'll go. Thanks everyone for joining our ASIC workshop on reliable ozone measurement at scale. We have a great panel here today to talk about the current state of ozone monitoring around the world and how we can use new ozone monitoring technologies to improve our understanding of the health impacts of this pollutant. So we have Owen Cooper, a senior research scientist focused on regional chemical modeling at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado. Also joining us is Gordon Pierce, the Technical Services Program Manager for the Air Pollution Control Division at the Colorado Department of Public Health and the Environment. We have Jessa Ellenberg, the Director of Educational Outreach at 2B Technologies, and Paolo Michelizi, Chief Technology Officer at Clarity Movement. So I would like to remind everyone that there will be a live Q&A session at the end of this event. So please remember to submit any questions you have for our panelists through the Q&A box. And with that, I think we'll go ahead and get started. And first, we're going to hear from Owen, who leads the International Global Atmospheric Chemistry's Tropospheric Ozone Assessment Report. And Owen will share how deploying additional ground level ozone monitoring stations will improve our ability to effectively assess surface ozone trends and quantify global human exposure. I'll pass it over to you, Owen.
Great, thanks for the introduction, Ryan. We can move on to the next slide. So this presentation will try to answer two questions. First of all, what is the global distribution of surface ozone monitors? And two, where are the major gaps in terms of spatial coverage and population? I'll be relying on two main data sources. The first is the Surface Ozone Database of the Tropospheric Ozone Assessment Report, or TOR. We'll also be looking at data from the Chinese National Monitoring Network. And we'll look at these observations in terms of the health impacts and air quality guidelines from global burden of disease and the new WHO Global Air Quality Guidelines. Next slide, please. So briefly, the Tropospheric Ozone Assessment Report has a mission to produce up-to-date scientific assessments of tropospheric ozone's global distribution and trends from the surface all the way to the tropopause. We've built the world's largest database of global ozone metrics with observations from over 10,000 stations worldwide. And importantly, all data are quality controlled. Next slide. So in the first phase of tour, we had the global database updated through the end of 2014. We're now in our second phase, and we'll soon have the database updated with data through the end of 2020. And all of these data are open access. Next slide. So this is really the first global scale view of all available surface ozone observations. This came out of the first phase of tour. This particular figure shows the 98th percentile during the summertime months around the world. So we're focusing on high levels of ozone pollution. And this is a 5-year average over 2010 to 2014. And for this time period, we had about 4,800 sites available worldwide. Next slide. So this is the same metric, but now we've just zoomed in on North America, Europe, and East Asia. And there's definitely areas of the world with very dense ozone monitoring networks. But even so, only a small percentage of the world's population lives close to an ozone monitor. Take, for example, California and France, where we have very dense networks. Regardless, only less than 10% of the population lives within 5 kilometers of an ozone monitor in these regions. Next. But things are getting better. This is a map of the new Chinese ozone monitoring network. And just in the last few years, China has established some 1,600 sites in 454 cities. Next slide. So this is a map of the world. It's not your typical projection. This shows the countries of the world where their size is proportional to population. So this is just a good way to look at the uneven distribution of ozone monitors around the world. So if we can go to the next region. Okay, this is the number of ozone monitors per 100 million people in North America. So there's about 426 monitors per 100 million people. And the next region is Europe. They also have a lot of monitors, 314. And the next region is Australia and New Zealand with 212 monitors per 100 million people. Now, if we go to the next region, South and East Asia, now we see the numbers are really falling off. Even with China's 1,600 monitoring sites, there's only 81 monitors per 100 million people. And from there, the numbers dwindle even more. If we go on to South America and Central America, it's just 10 monitors. The Middle East, it's just 5 monitors. And Sub-Saharan Africa, only 3 monitors per 100 million people. So this figure very quickly shows you the disparities in ozone monitoring worldwide. Next slide. So what does the ozone monitoring distribution have to say for us in terms of air quality guidelines and human mortality due to ozone? Well, the World Health Organization just released this updated global air quality guidelines. And in terms of ozone, they have a new guideline that focuses on peak seasonal ozone. So this is a rolling 6-month metric based on maximum daily 8-hour average ozone. So it's basically the peak 6-month maximum of MDA8 ozone. And that guideline is quite low. It's only 60 micrograms per cubic meter, or 30 parts per billion. This figure, produced by my colleague Kailan Chang at the University of Colorado, shows this ozone metric averaged over the years 2008 to 2014. So light blues, greens, and the warm colors, they show the portions of the world that currently exceed this WHO guideline. And really, it's only in the tropics and Australia, New Zealand, and Southern South America where ozone is less than 30 parts per billion. So most of the world's population is exposed to ozone levels above this new WHO guideline. Next slide. Now, global burden of disease, in their estimates of global mortality due to air pollution, they use the same WHO metric. And what I'm showing here are results from the latest GBD analysis for the year 2019. So the top panel shows estimated global mortality due to ozone pollution for both the globe in black and in different regions of the world in the colored lines. And this is for the years 1990 through 2019. And then the lower panel shows global mortality due to ambient PM 2.5. And note the very clear difference in the scales on the y-axis there. So the take-home message from this graphic is that global mortality due to ozone and PM 2.5 pollution increased from about 2.3 million in 1990 to about 4.5 million in 2019. And about 90% of the premature deaths are due to particulate matter. In 2019, the estimated ozone mortality worldwide was about 360,000 premature deaths. Next slide. So GBD can't produce global estimates of air pollution worldwide based just on sparse observations. Instead, GBD uses a blend of observations and output from 9 global atmospheric chemistry models. And both the TOR and the Chinese monitoring network data are used to bias correct the models and to select the models that are most accurate. So the figure here to the left, this just shows all available ozone observations in 2015. And you can see that most of the world is not covered. But for the same year in 2015, this is the GBD ozone exposure map. And this is based on a blend of observations and these 9 global models. And so from this figure, you can quickly see that the highest ozone exposure is found in Southern California, the Middle East, South Asia, Eastern China, and South Korea. And if you go on to my final slide, this is a nice table here. This is produced by the Health Effects Institute in Boston, and they published last year a very nice analysis of the GBD results. And they made a list of the top 10 countries with the highest ozone exposures globally in 2019. And of these 10 countries, 9 of them are in the Middle East or South Asia, shown by the blue circle in the map. And within that blue circle, you can see there are very few ozone monitoring stations. So the GBD estimates for mortality in this region is mainly based on models. And really, it's going to take extra observations in this region as well as Africa and South America to really improve the GBD estimates for global mortality worldwide. And with that, I'll end my presentation. Happy to hand it over back to Ryan.
Great. Yeah, thanks, Owen, for sharing your work with TOR. It's great to know that your team's working to make global ozone data more accessible, and I would invite anyone interested in learning more to check out the TOR database. Just a reminder that all the data there is open access. Yeah, and next we're going to hear from Gordon, who will share some of the ozone monitoring work that is currently underway in the state of Colorado, and discuss some of the limitations that could be addressed with additional ground level ozone monitoring equipment. So over to you, Gordon.
Thanks, Ryan. So as Ryan mentioned earlier, my name is Gordon Pierce. I'm with the Colorado Department of Public Health and Environment in the Air Pollution Control Division. I supervise our technical services program, which includes all of our ambient air monitoring across the state. Next slide, please. So just to provide an overview, the Denver North Front Range of Colorado is currently designated as a non-attainment area for ozone. It's our only non-attainment area for any pollutant in Colorado. We're in non-attainment for both the 2008 National Ambient Air Quality Standard of 75 parts per billion, as well as the 2015 NAAQS of 70 parts per billion. We're currently classified as serious under the older standard and are going to be downgraded to severe in 2022. And similarly, with the newer standard, we're currently marginal and are going to be downgraded there as well in next year. So over the years, we have implemented many controls, a lot of new regulations, particularly on the oil and gas industry, and a lot of emissions reductions have occurred over the years. A lot of the new, for instance, a lot of the new federal requirements on oil and gas have actually been based off a lot of the regulations that we put into place a number of years ago. What we're seeing now in our ozone state implementation plan modeling work is that vehicles and as well as oil and gas development are the 2 major anthropogenic sources. And you can see this on the right-hand side of this slide. Light-duty vehicles contribute, at least on the day that was modeled here, contribute about 5.7 parts per billion. Oil and gas area sources about 5.3 parts per billion to the ozone. And you can see in the list that other oil and gas, the point sources, oil and tanks are on this list as well. And then for vehicle type of traffic, there's lawn and garden and construction equipment, the non-road equipment. So it's all part of the top end of this list. The other big issue, though, that we do deal with is background concentrations. And you can see that at the very bottom, where on this particular day, over 45 ppb was from background. And that's a combination of what's coming from out of state, as well as sort of natural ozone, as it were. But that leaves us with, and if you add up all the rest, we're looking at just over 30 parts per billion. So it shows that we don't have, it makes it tougher for us as there isn't as really that much anthropogenic that we have to control versus what we can potentially see as far as background. Also with exceptional events, those come into play as well with stratospheric intrusions in the spring and wildfire smoke, especially in the summer these days. And as we know, wildfires are becoming more and more of an issue. Next slide, please. So we have had a long history of monitoring in Colorado for ozone. We have 21 ozone sites ourselves, and then other federal agencies have their own existing networks of sites, National Park Service, BLM, Forest Service, EPA, and NOAA has some as well. In addition, some of the tribes, the Southern Ute and Ute Mountain Ute tribes in Southwest Colorado have ozone monitors, and local agencies such as Denver, Weld County, Garfield County, and Aspen, and then other private networks such as the Go3 network. This still, when you consider the number of monitors, and we're trying to cover an area of over 100,000 square miles and a population of about 5.8 million, it does get pretty limited as far as the coverage. And we do see a need for more monitors for public information and for forecasting. We do short-term monitoring as well. We have about 6 portable monitors based on the 2B Technologies 2005 model ozone analyzers. And you can see a picture here in the lower right of one of our setups that's out in the field. We perform these special studies in different areas of Colorado every year, trying to identify areas that have not been monitored in the past, or where we feel we need more monitoring, and where is going to be the best location to put in a permanent monitor. Problem is, these data are not immediately available to the public, and they're just a one-time snapshot over that summer. The U.S. Forest Service also has a number of monitors that they put out in the summer for potential forest impacts from ozone. Next slide, please. So here's with the state of Colorado and all the ozone sort of near regulatory or regulatory monitoring sites shown on here. The red are ones that we own and operate, and then what's in blue are other agency monitors. And as you can see, there's I've just kind of put some yellow or orange kind of circles or ovals on this map, and you can see there's a lot of unmonitored areas. And it's not to say we have never had monitoring in a lot of these areas. We have monitors in a lot of these areas in the past. We haven't necessarily seen any issues, or either that, or we just haven't had the resources to keep monitoring in these areas. We are going to be adding a monitor in Pueblo next summer, so that will cover some of the area in the one sort of lower center circle. But there's still big gaps, and while they may not be the highest population areas of Colorado, there still are people in those areas. And you can also see where most of our monitoring is focused in the non-attainment area, which is kind of outlined in that purple box. Next slide, please. So some of our concerns, and also you can see on this, the Go3 project, there's schools where there are ozone monitors, and this day that I looked at a few days ago, all the sites that have the kind of the whitish outline on them there, those are sites that are in operation at the moment. Just the red flags are ones that are where there are schools with monitors, but they're not necessarily operational. So you can see there's a fairly good coverage, but there's still big gaps across Colorado that are unmonitored. That is really our big issue. We just have a lack of information in potential high concentration ozone areas. Like I said, we don't necessarily see that all of Colorado has monitoring, but still for forecasting and for public knowledge, it'd be nice if there was more. The Front Range Foothills is one area of concern. Regulatory analyzers are great, but they're typically large, need temperature-controlled environments, and they need a lot of QA/QC. Low-cost sensors are definitely out there, and they're getting better, but they still have issues with them. Next slide, please. So with the Front Range Foothills, it's an area outlined here in blue where the population is increasing, very complex terrains with drainages in the valleys and all the mountains. And yes, there's a few monitors, but not a lot. And we have seen high concentrations up and over the continental divide. So just data from a couple of studies, one from the 2014 FRAPE study, and these were from aerial flights. You can see the flight paths, and where the red is the high ozone concentrations, and the longer kind of vertical line on the west side, on the left side, is right along the continental divide pretty much, and or near the continental divide, and you can see high ozone levels. From the study we did in 2017 that went up and from the Denver area up and over the divide, you can see there's quite a variation in the ozone concentrations, and depending on elevation. You can see the time of day differences, such as mine's peak, which is more towards the west with the blue line. It tends to be a little later in the day as far as the higher concentrations. But so this is definitely an area of concern for us where we would like to have more monitoring for the public. So next slide, please. So just to kind of summarize here, ideally, what we would like is for a state level as a regulatory agency and being able to provide data to the public for information and for forecasting, good, cheap systems that produce acceptable data would be our ideal. It doesn't necessarily have to be at regulatory grade, but something that's more autonomous, very weather tolerant, with the temperature variations we get in Colorado, especially the cold and higher elevations as well. Solar powered, different types of connectivity would be nice as well. Cellular, you can get in a lot of areas, or maybe Wi-Fi, but there's a lot of areas where you can't necessarily, so satellite connectivity may be something worth looking at. Small sensors, be nice if they are better, or at least have better methods to reduce the cross interference on them. Good public data displays, and in the ideal world, standardized data formats from the different manufacturers. I realize that's a kind of a pipe dream, but that would be an ideal. Next slide. And I will take Q&A questions at the end, but just a couple of our sites, and you can see just quite the variation in weather conditions. Back to you, Ryan.
Great, thank you. Thanks, Gordon, for that presentation and for sharing some context on the ozone monitoring work being done in Colorado. So next we are going to hear from Jessa, who will talk about some of the ozone monitoring work that 2B Tech has led around the world with the GO3 project, and also share some detail about the ozone monitoring technology that 2B Tech has developed and that underlies the Clarity Ozone Module. So over to you, Jessa.
Thanks so much, Ryan. And thank you so much to Gordon and Owen for sharing your perspectives on global and local ozone measurements. As Gordon mentioned, we have been working with Owen and Gordon for a long time now, beginning about 10 years ago when we created the Global Ozone Project, or GO3 project, that Gordon mentioned in his presentation. In the GO3 project, we sent 2B Tech ozone monitors to schools around the world so K through 12 students could measure and learn about ground level ozone. They shared their data online to compare with GO3 measurements from other schools in other locations. And this map shows the locations of the schools that participated in the GO3 project. The top picture shows the equipment that we sent the schools, which included the 2B Tech ozone monitor, a computer, and a Davis weather station. And I included the picture of the students because it's one of my favorites, and it was a very proud moment for us. So this is a picture of when Estes Park, school in Colorado, Estes Park High, became the first ever GO3 project school. And in this picture, they're calibrating their ozone monitor with a portable 2B Tech ozone calibrator. So we were really excited to kick off the GO3 project, and it's been quite a journey over the last 10 years. So because we ran that project for such a long time, we were really excited when Clarity approached us about partnering on an ozone module, because it really presented the opportunity to expand ozone monitoring capabilities worldwide. And our experience with the 100+ ozone monitors used by students in the GO3 project really demonstrated what we already knew or suspected, that UV absorbance ozone monitors can produce accurate data for many years with very little intervention, making them really the perfect instrument for worldwide deployment by experts and non-experts. And I'll have the next slide there, Ryan. Thank you. I thought it'd be fun to just quickly look at some data that were collected by the students. This is some data from Lima, Peru, and then also data collected in Pinedale, Wyoming in the United States. And in Pinedale, the students were actually able to observe then recently discovered phenomenon of wintertime ozone formation near oil and gas drilling. So that was really an impactful, interesting experience for the kids there. I'll take the next slide, Brian. Awesome. So since we've talked a little bit about UV absorbance in this webinar and mentioned that measurement principle, I'd like to take a quick moment to step back and explain how a UV absorbance ozone monitor works and why it can produce reliable data for many years. So this method of measuring ozone is considered a gold standard and is recognized by the US EPA as a federal equivalent method. To explain how it works, I'll use some screenshots from a video we made for the Go3 project students, explaining how a UV absorption ozone monitor works. I encourage you all to check out the link provided here for the full video. The measurement principle at work here is exactly how the ozone layer keeps us safe from harmful UV rays from the sun. Ozone absorbs UV light at a wavelength of 254 nanometers. A pump brings air into the ozone monitor, and we use a lamp that produces light at 254 nanometers, and we measure the amount of light that gets blocked by ozone with a component called a photodiode. Here you can see the ozone molecules blocking some light from reaching the photodiode. So you can see it, on the right-hand side, you'll see the photodiode and the UV lamp. And as the ozone comes into the monitor, it blocks some of that light produced by the UV lamp or absorbs it. And the photodiode sees less light intensity. So that's how we calculate the amount of ozone present in the sample. The reduction in lamp intensity allows us to quantify the amount of ozone with the Beer-Lambert law, which I'll explain a little bit more in the next couple slides. Next, okay, perfect. Okay, so there are really two phases in the operation of an ozone monitor. The first phase is where ozone is scrubbed from the air and removed completely, and the intensity of the lamp is measured with no ozone present. So that's phase one, and that establishes your I0 value. And then in phase two, the valve switches and ozone is allowed to pass through. So the ozone passes through the detection cell, blocks some light from the UV lamp, and that light intensity is measured and becomes the I in the equation. And then Ryan, I'll look at the next slide for great. So that I0 and I go into the calculation of the Beer-Lambert law, which ends up giving you concentration of ozone in molecules per cubic centimeter. This is referred to as an absolute measurement technique because it makes use of the fundamental knowledge of how much light an ozone molecule blocks. This differs from ozone sensor measurement techniques, which rely on components that can get consumed over time, affecting sensitivity and baseline drift. So ozone sensors also respond strongly to other compounds found in the air, like nitrogen dioxide, sulfur dioxide, and VOCs in the case of heated metal oxide sensors. So this makes it necessary to replace sensors on a regular basis. And I'll take the next slide. Great, so the UV absorption measurement principle allows us to achieve really high precision and resolution in our ozone monitors. The Clarity module uses the 108L pictured here, which can detect down to 3 ppb of ozone and has a precision of 1.5 ppb. So I find this pretty incredible, knowing that if you circled the Earth with golf balls, it would take 1 billion golf balls. And so if you painted 3 golf balls yellow, you would be able to detect those 3 golf balls. So I love thinking about this when conceptualizing the idea of a part per billion. So Clarity's choice to use a UV absorbance measurement technique is really exciting for a lot of reasons. First and foremost, it presents the opportunity to characterize ozone in places it is currently not measured and can do so in a way that produces data that can be trusted. Additionally, its ability to produce reliable data for many years with little intervention, makes it a really great choice for ozone network expansion all over the world. And I'll send it back over to you, Ryan.
Great. Yeah, thank you for the great presentation, Jessa. And next, we're going to hear from Paolo, who will talk a bit about the engineering work we did to integrate the ozone module with the Clarity Node S and discuss some of the applications that we see the ozone module being used for, including a case study of how the ozone module is being used today. So I'll hand it over to you, Paolo.
Thank you, Ryan. Hi, everyone, and thank you for joining us on this workshop. Some of you in the audience might already be familiar with Clarity, but I'd like to just provide a little bit of context. So at Clarity, we serve organizations such as government agencies, municipalities, industrial facilities, community groups, and research institutes. And what we do is we offer them reliable air quality measurement at scale. We want to enable them to monitor air pollution at key locations that were previously unmonitored. And how we do it is through our vertically integrated solution that includes our IoT hardware that's shown here, the Clarity Node S. It's fully solar powered and connected to the internet through the cellular network. And our cloud software that manages sensors on the field, runs QA/QC algorithms on the data, and serves the data through dashboard and APIs. And also an important part is our remote air quality experts who help customers to perform remote calibration, troubleshooting, and to draw insights from monitoring data. So how our solution differs from others is that all of this is bundled up in a sensing as a service model, meaning that we charge an annual fee and we provide everything you need to monitor pollution at the site. So you can focus then on looking at the data and finding answer to your question rather than operating this vertical stack of the system. And with this method, we have experience with traction. Next slide, please. Our solution is today deployed in more than 60 countries and using very exciting projects. Next slide. As an example, in London, we monitor PM2.5 and NO2 at more than 300 sites. And some of them are sensitive sites, such as schools and hospitals. And we are helping to shape up the future clean air policies there, which is very exciting. And also by working on all these projects, we now know that we can provide valuable particulate matter and NO2 data with our approach. But we have also heard from our customers a lot of questions around air quality going beyond PM2.5 and NO2. Next slide. To respond to this need that we heard from our customer by working really globally, in October, we announced a major update to our product. So now our Clarity Node S supports add-on modules that enhance its sensing capabilities, making it a monitoring platform. This allows us to work with the world's best instrument makers, such as our friends at CDPHE, and offer the benefit of both best-in-class sensing technology and ease of deployment, vertical integration, and remote expert support. Next slide. One of our first other modules, besides the wind module and the black carbon module, is the ozone module. It is developed in partnership with CDPHE based on their Model 108L, and it offers FEM-grade measurements. Here you can see how the module plugs in right in the Node S, and the data flows to our dashboard for advanced visualization and to our APIs for integration. We are especially excited about offering ozone monitoring. In fact, ozone is the most requested parameter by our customers, and ozone attainment is of concern across the US, Europe, and elsewhere, as we saw. Next slide, please. Now, ozone is a little bit different from particulate matter and NO2 because of how it is formed. Being it a secondary pollutant, it tends to be more uniformly distributed spatially. So we believe that for ozone, very accurate regional characterization is of more interest than indicative block-to-block monitoring. We see this as an opportunity to propose our first FEM-capable solution. This way, our customers can create a hybrid network that is dense for those parameters with high spatial variability, such as PM2.5 and NO2, and more sparse but extremely accurate for the regional characterization of uniformly distributed pollutants such as ozone. And this approach is already at work. Next slide, please. Here we show a project in Grand Rapids, Michigan. Prior to the implementation of this network, there was only one reference monitoring station there. Now our friends at Just Air, that is an air monitoring solution provider in charge of deployment, management, and development of custom data solutions and visualizations. They have deployed 11 Node S and 1 ozone module. So this has enriched the data set available to the Grand Rapids community by 1 order of magnitude. And it's really allowing them to study and highlight disparities in air quality for disadvantaged communities, which is the focus of the project. which is really nice. So next slide. Really with this positive note, I'd like to end this presentation. And if you have any additional questions, please feel free to visit our website at clarity.io or to drop a line at contact@clarity.io. And thank you very much for the attention. And I'll send it back to you, Ryan.
Great. Well, yeah, thank you, Paolo, and thank you to all of our panelists for the great presentations. Yeah, hopefully we have a lot of questions from the audience here as we move to our live Q&A. Just another reminder to everyone to please submit your questions through the Q&A box Zoom function. So thanks again, everyone, for joining, and look forward to your questions.
Okay, so we are now going to move to the live Q&A portion of the event. We've already gotten a lot of great questions in from the audience, so thank you, everyone, for your interest and for keeping the conversation going here. I think we'll start with a question for Gordon. So we had somebody ask, so if this ozone data from these monitors, which are FEM capable but not necessarily operated in compliance with FEM guidelines, so if it can't be used for regulatory purposes or enforcement, what is the value of the data to a state agency like yours, and how would you see these monitors being used?
Sure. So I think as far as enforcement, it depends. There are times I think they can be used for enforcement. I think as a regulatory agency, we would need to know more as far as the quality of the instrument, of the sensor. Especially for PM, they tend to be a lot better than some of the other pollutants. So that there would be an issue. That would be the first question. So that I think they could be used. And they certainly can be used for informing if there are potential issues that need further investigation or follow-up work. There are certainly cases where, from sensor monitoring, we have sent inspectors out to look at, do a closer inspection of what's going on at the facility. Beyond that, they are very useful just for providing the information, providing the public additional information on air quality in their area. We can't put out regulatory monitors everywhere, too expensive for the initial cost and for maintaining them, but they can provide a lot more just general information to the public.
Great, thanks. Yeah, I can definitely see how more measurement points helps you just get more holistic picture of what's happening with air pollution in the region. So great, thank you for clarifying that. Let's go to a question we had for Jessa next. So this question was from Evan, and it sounds like in the region where he's calling in from, they face high PM10 and PM2.5 along with ozone, especially during fire events. And he's interested to know how well these ozone monitors work during like wildfire events.
Yeah, so I can answer that, and Gordon, also please chime in here if you have anything to add. Ozone monitors, UV absorbance ozone monitors work very well during fire events, and likely will not see any type of interference in the measurement. I also have a related question about from Peter asking if the scrubber removes only ozone or does it remove aromatic hydrocarbons as well. And so those are kind of related questions, because if you do have a very large presence of volatile organic compounds in the air, that can be an interfering compound for a UV absorbance ozone monitor. But those levels have to be very high. Typically, we only see interferences in an indoor environment or oil and gas drilling. And Gordon, maybe you have anything to follow up or add on that.
Sure. So yeah, as far as wildfires go, we have seen some interferences actually on our photometric ozone analyzers, especially, and this is also research that's been done by Dan Jaffe up in the University of Washington also has seen this, especially if the fire is close and you do have a lot of hydrocarbons from that smoke that are interfering. Once you get more of a long-range transport of wildfire smoke. It tends not to be much of an issue. To get around it, you really have to go for something more like a chemiluminescent ozone measurement technique rather than the photometric.
Great. Well, yeah, thanks, Jessa and Gordon, for weighing in on that. And hopefully that cleared things up for you, Evan, and others. Certainly important to be monitoring air pollution during those types of events where concentrations of both PM and ozone can be very high. So let's go to a question from Paul, who it sounds like Paul is located in Kenya, and he's wondering if these monitors and sensors are available in Kenya and other parts of the world. I think that one was for you, Paolo. Send it over to you.
Thanks, Ryan, and thanks, Paul, for the question. Yeah, I think we would, of course, love to support the deployment of such monitors in Kenya. I think this approach of indicative monitoring has been very well received in developing countries, where sometimes the budget and the operational burden of deploying a vast network of regulatory monitors is a blocker. So we do actually have a few projects in the African continent already. I think that the main one we have right now is in Kampala, Uganda, with KCCA, which is the official environmental agency there. We have about 20 devices, and these are used for the first time to monitor air quality in the region and to start drafting also some regulation and policies. So we are very excited about the work being done there and that we can support it. I think apart from cost, also the ease of deployment, the fact that the devices are solar panel, powered through solar panel, and also connected to the cellular network is very good there. Of course, we always do recommend to have regulatory monitoring in place, at least a site on which we can then calibrate our indicative monitors upon. We have worked with customers. This project is in Western Australia, actually, where there was very few monitoring, and we helped them to bring in one regulatory monitor and then a vast network of sensors. So with this hybrid approach, which is similar to what we are proposing here for ozone, where we propose, since these are highly accurate instruments, where we can have a few of those for characterizing the regional concentration. But I think in general, yes, we would love to support this type of project in Kenya. And I send it back to Ryan.
Great, thanks, Paolo. Yeah, so certainly we would love to see some of this equipment deployed in Kenya and elsewhere. So we have a question for Jessa from Jerry about any issues with relative humidity or other potential conditions that might affect ozone readings. And I imagine Gordon may be able to weigh in on this as well from what he's seen in Colorado. It sounds like there are also topographic factors that may influence ozone concentrations. But yeah, I guess maybe Jessa, would you like to address this one first?
Yeah, thanks, Ryan. So there were two sort of related questions, separate questions, but asking about temperature and also humidity. So first of all, humidity, we're able to mitigate the effects of humidity in the ozone measurement by using a Nafian dew line, and that equilibrates the humidity for the sample, the air sample, and as well as for temperature. The ozone monitors are designed to go down to very extremely cold temperatures. There are some techniques that we use if the temperatures are going to be very, very extreme. But some of our ozone monitors are buried in our ice sheets in Antarctica, and Gordon has some in all kinds of crazy places. So if he has anything to add for that too, but yeah, humidity and temperature are not problems for the TÜBİTAK ozone monitors.
Yeah, I'd agree. We haven't seen too many effects there. When you get to more of the electrochemical small sensors, then they definitely it is an issue. But yeah, not for really so much for the photometric, especially with the dryers on board.
Great. Yep.
Great. Well, thanks, Justin Gordon. Sounds like this technology can work in a wide range of environments, which is great. And I do think we need to wrap up shortly here, unfortunately, because we do have still have questions coming in, but we'll be sure to follow up with anyone whose question was not answered live following the event. And thank you everyone for your interest. It's exciting to see this many questions coming through. So one final question was about the availability of the ozone module and pricing as well. So Paolo, is that something that you could address?
Yes, we are today we are accepting orders for the ozone module. So that's a nice question. I'm happy to hear someone is interested. And the first devices will be delivered. I mean, we're already delivering, but expect to deliver in Q1 if you order now. And for pricing, we really want to understand the type of project you're planning. So I would suggest to contact us at contact@clarity.io so we can start a conversation and understand what you plan to do and make a quote and take it from there. And thanks, Ryan.
Great. Yeah, thanks, Paolo and Sandra. I think we're just about out of time here. So yeah, let me just say thank you again to all of our panelists for the excellent presentations. And I forgot to mention at the beginning of the Q&A, Owen was not able to join because he's actually presenting at another conference on TOR at the American Geophysical Union Conference. But if anyone has questions about TOR specifically, please feel free to reach out to us with those questions and we'll get you in touch with Owen as well. And yeah, Sandra, any closing comments?
Nope. Thank you again, Paolo, Gordon, Jessa, and Ryan for the wonderful presentation. To all our attendees, thank you for joining us. And please watch your email tomorrow for the recording to come through that you can share with colleagues and coworkers. I hope you all have a wonderful rest of your day.
Thank you so much. Thank you, everyone.